Okay, let's start. So question for this session, actually we will do an exercise on the plane rotation method. Actually, when the line rotation method becomes difficult, in this case actually the line rotation method is a bit difficult also. We can do it in line rotation method, but it is a bit difficult. So we use the plane rotation method for our convenience. Not every problem can be done with the easy in plane rotation method. Some problems are easy to do it in plane rotation method, but some of them are difficult to do it in using this plane rotation method. So this is the question. A line AB of length 130 millimeter has its end A 52 millimeter in front of VP. HT of the line is 44 millimeter in front of VP, and its vertical trace VT is 50 millimeter above HP. If the distance between HT and VT is 110 millimeter, draw the projections of line AB and find its inclinations with HP and VP. So here the true length of the line is given, not the true inclinations are given. So only true inclinations, true length of the line is given. Then one end, the distance of one end from VP is given, the HT of the line is given, and VT is also given. And the distance between HT and VT is given. So this is it. Not out the question, and then we can continue. Okay, now let's insert our base figure for this one. You just note the base figure for this case also. Those who haven't noted it down, just note it down. This one is required for, it is better to use this particular figure for solving problems which using this plane rotation procedure. You can note it down roughly, not an actual representation is required. So here what the data that are given is the true length. The true length is 130. Here also the true length is 130. Both the true lengths 130. Then the point A is 52 millimeter in front of VP. Point A is 52 millimeter, means this distance should be 52. If this distance is 52, this distance should also be 52. This is our condition. Both these distances should be of 52 millimeter length. That's our condition. Then the HT of the line is 44 millimeter in front of VP. The HT, that is this distance is 44 millimeters in front of VP, and its VT is 50 millimeters above HP. So this distance is 50 millimeters above HP. And the distance between the end projectors, that is the distance between this line, the distance between HT and VT. So sorry, the distance between this line and this line, that is, if we consider this distance should be equal to 110 millimeter. Distance between HT and VT is 110. This distance is 110. So these are the data that are given. So we first start with the point HT. Let's start with the point HT because we doesn't know where the point A dash will be. So, but once you find out HT, then you can go for H dash. And VT, once you go for VT, you can find out V. So first what we draw is we draw two projectors in which the HT and VT are lying. So this is our XY line, and this is the projector for HT, and here is the projector for VT. The distance between these two lines is 110, that we have already mentioned. So this is the first steps. Then we go for our HT. First we go for HT. So here is HT, that is 44 millimeter in front of VP, and H dash. Here it is VT, that is 50 millimeter above HP. So these distances we can first mark. these values, so these points also we can mark, that is HT, H dash, VT, V dash. I mean not V, not V dash, it is V. Now we know that from this point, we know that HT and H dash, not HT, H dash and VT are in the same line. HT and V dash, sorry, H dash and VT, H dash and VT are in the same line. H dash and VT are in the same line. So we can join H dash with VT. Likewise, HT and V are in the same line. HT and V are in the same line. So we can join HT with V. HT with V, we can join. Now, it is said that A is 52 millimeter in front of VP. So 52 millimeter in front of VP. So the point A should be lying 52 millimeter in front of, below the XY line. So below 52 millimeter, 52 millimeter below the XY line, we draw the locus of A. So this is the locus of A. Now we know that the point A is in the line which is in the same line as HT and V. So we have to extend that particular line, extend the line HT and V towards the left. In our base figure, even the point A is lying in between HT and V. That means the A is nearer to XY line than our HT. But in the question, the given question, our point A is somewhat farther away from our HT. So that is why this is lying below the locus of A is below our HT. Now this is the point A. Now point A is obtained. Now from this one you can find out the point A dash. In order to get the point A dash, you have to point A dash is C. Point A dash is in H dash and VT. In the same line joining H dash and VT. So that line you have to extend. So here you can get the point A dash. Point A dash is obtained, point H dash is obtained, point VT is there, point A, HT and V are there. Now what we have to find out is, we have to find out the points A1, B1, A2, B2 and B dash and finally B. These 6 points also we have to find out. Now from this A dash, you can complete that projector. This line is actually the projector for A and A dash. That projector you can complete. And this distance, this particular distance, this small distance, this distance corresponds to this distance. These two distances are similar. And this larger distance, this distance is similar to this distance, this 52 millimeter. That is 52 millimeter. This small distance is equal to this small distance. So that's it. Now we draw this distance, this small distance towards this side of HT, I mean this side of AB, so that this distance is equal to this distance that we know. This distance should be equal to this distance. So we draw this distance to here, so that we will get point A2. Point A2 is obtained. Now we know that point A2 and HT are in the same line. Point A2 and HT and B2. HT, A2 and B2 are in the same line. So we join A2 with the HT and extend it. So, and this total distance such that the total distance A2 B2 is 130. 130 is our true length. So B2 from A2 to B2 it is true length. So HT, A2 and B2. These are this length, the A2, HT, B2. This total distance will be 130 millimeter. So that is there. Then you can join B2 with a line which is perpendicular to this line. The line should be perpendicular to this A and V, AV line. This line should be perpendicular to this AV line. So that corresponds to this line. This line is corresponding to this line. So that is there we can obtain the point B. Now A and B can be joined together to form the top view of the line. Now you can project B to the front view, the line representing the front view, so that this point will be B dash. This is point B dash. Now join A dash with B dash. So this is the true front view. Then, in order to get the true inclinations, you have to find out A1 and B1. So in order to get A1, draw a line which is perpendicular to A dash B dash through A dash. That is corresponds to this line, this 52 marked line. So that line is marked. This is point A1, and from B dash, draw another perpendicular line. This length corresponds to this same length, this length. So that is this distance. This distance and this distance are same, that we know. So that particular length, this distance as well as this distance, same length. Then that is the point B1. Now join A1 with B1. This is again true length. So now extend A1 B1 line to VT, and this angle is phi, and here this angle is theta. The inclination at the inclination AB, line AB makes with the A2 B2. Line AB makes with the A2 B2 is theta, and the line A1 B1 makes with the A dash B dash, that is angle phi. So this is final figure, and finally you have to find out what is the value of the true length, theta, phi, alpha and beta. That also you have to find out. So let's do it once more. So we start with our XY line, then the projector for the HT and projector for VT, which are at 110 millimeters apart. Then the HT is marked. HT is 44 millimeter in front of VT. HT is marked as well as H dash is marked. Then VT is marked and V is marked. H dash and VT are in the same straight line, so it is being joined. Then HT and V are in the same straight line, they are joined. Now we know that the point A is 52 millimeter in front of VP. So 52 millimeter in front of VP, we draw a horizontal line, that is the locus of A, and we extend the HTV line. That line intersecting with the locus of A will give you the point A, and extend the line H dash VT and project the point A to the line H dash VT. And the line H dash VT actually represents the front view, and HTV represents the top view. And the point A dash is obtained. And then the distance of A dash is projected or actually drawn at point A. So in a line which is perpendicular to AB, the line AB, a line perpendicular to AB is drawn, and in that one the distance of A dash from XY line is marked, and hence we obtain the point A2. Then point A2 is marked or joined with the HT and extended. Point A2 is joined with the HT and extended, and that distance of A2 B2 is 130 millimeter. Likewise, we obtain the point B2, and then from point B2, a perpendicular to the line AB is drawn, and thus we obtain the point B, and the AB is joined with the thick line. Then point B dash is obtained by drawing the projector. Then A dash B dash is also joined. Then from point A, a perpendicular is drawn, and A1, point A1 is obtained. Then point B dash, a perpendicular is drawn, to obtain the point B1. Join A1 with the B1 and then extend that particular line to VT. So then finally you find out the true length, true inclinations, then alpha and beta. That's it. Now let's do it in the open board. 52, 44, 51, 130. So here ST is 44, A is 52, VT is 50, rolling is 130, distance between ST and VT. This is 110. That's it. So this is line XY. Now two perpendicular lines at distances front and so first one perpendicular line. Then from here this one 110 millimeter. The second this is just to give the dimensions, not no other usage for it. So this is 110. Now what we need to draw is we need to find HT and H dash. HT is 44 millimeter below the XY. then BT is 50 millimeter. So I'm just marking all these points and then I'll give the names. Okay. Point HT, point HT, and here is point H dash. Here is point BT. This is point V. This point V. Now we join the points VT with H dash. I am extending it so that anyway I need the extension, so I am extending it. Likewise, join V with the HT. Here also we need the extension, so extending it. So these two lines are drawn. Now in order to get point A at length 52 millimeter below. I have already marked that distance, so no need to mark it again. So I'm drawing it here. This is the line that is 52 millimeter below XY line. This is now point A. A is here. Now if I draw a perpendicular line which is perpendicular to this one from here. Here is point A dash. Here is the point A dash. That much is done. Now what I need to do is I need to draw a line which is perpendicular to this AV. In order to draw that particular line, anyway I need a set square, protractor. Fix it at A and mark the 90-degree line, 90-degree here. And this distance, that also I need. So first I draw the line. Then I use that is a very small thing. I use a scale to measure the distance. Use a scale to measure the distance somewhere around 1.1 millimeter. So from this point I mark that 1.1. Distance here. Then join this point with HT and extend it. It should be extended in such a way that the total length should be 130. So I extended it some length. I'm not sure how much it is. Then from this point I need to mark 130. So this is the point. Now from this point I have to draw a perpendicular to this one. Now to draw it there are multiple methods. The method that I am using is not the perfect method, but I have no other option. Otherwise, it is very difficult for me to draw. But when you are using pen and paper, you can use any method. So in this method, what I am doing is I am not doing it perfectly, but drawing it approximately by moving my protractor through the line, and where it coincides with our perfect line. I mean, the point, I am creating it. But you use the method by which you can draw a perpendicular to a line from a point which is outside the line. It is given in our YouTube channel. It is in our YouTube channel playlist. It is given how to draw a perpendicular to a line from a point which is outside the line. So use that particular method. This method in open body, if I go for that one, it is very difficult. So now this is an approximate perpendicular. This is not an actual perpendicular. That's why I asked you to do the exact procedure. Now this is the point B. So here this point is A2. This point is A2, and this is point B2. Small b2, it is capital B. It's capital B2, and this point is small b. And now you can join this A and B with a thick line. This is it. Now what we have to do is we have to draw a perpendicular from A, sorry, not A dash. Or better, before that one, you find out the point B dash also. For that, you can find out the point B dash by drawing a perpendicular from B to line A dash H dash VT. So this is the point B dash. This point B dash. Now you join, draw a perpendicular from A dash and in this line mark a distance equal to 52 millimeter. 52 millimeter is the distance of point A from XY line. So that distance you have to mark. And to 4.8. That's again an approximate distance. Now join this point. This point is A1. This point is A1. Now join point A1 with VT.
Sir, what is the measure of A dash A1?
It is 52, the distance of A from the small letter A from XY.
Oh, okay, sir.
Yeah. So A1 VT we can join. Now from B dash, draw a perpendicular to this A1 VT line. From B dash, draw a perpendicular. So not this full line is required, but okay. I will use the scale itself. Now this is point B1. Now what you have to do is you have to measure this angle A1 VT A dash. That is the angle phi. This is angle phi. This angle. That is phi, and this angle you have to measure. This is angle theta. The true length is A1 B1 is true length. This length is true length A1 B1. That is 130. It has to be 130. So yeah, it has to be 130. That we already know. Then A dash B dash, that is the front view. That also you have to mark it as dark line. A dash B dash, that is also a dark line. So that's the drawing. Now you complete the dimensions, that is 50, 44 and 52, then 130. In that you can leave it in the box.